Hey everyone, it's Dr. Tracy, and here's a weekly video for CISPROG 5 Fundamentals of Python to help you know what you should be doing this week in case you're having any difficulties navigating Canvas. I sent out announcements this week. They should go to your Panther email. If you didn't get them or you can't check them or whatever, you can always click on the Announcements tab to the left of the screen to find out the announcements that I've sent. And I've sent quite a few just in the little time we've been together. The announcement I sent out that says This Week in Prog 5 is a description of the things that you should be working on this week. This week, like every week, there's an assignment, a discussion, and a quiz related to the topic that is presented. This week, the focus is on software development. So it's very specifically on how to develop a program and nothing to do with Python at this point, because we're talking about the process of software development rather than the language that you use to develop the software. The chapter 2, has been broken up into two parts because it legitimately describes two different things. It describes the history of computing and software development and the process for developing software. And then next week, as you'll see, we'll get into the programming aspects of taking those that you designed and putting them into code. The coding part of software development is, I won't say it's the easy part, but it is definitely the least important part. If you build a solid foundation of planning and you have a design and analysis of what you need as a program and how you can get there, and you create an algorithm that solves a problem before you ever start to code, then simply translating that algorithm into language syntax is easy work if you're fairly familiar with the syntax. I've added some additional resources for software development in addition to a PowerPoint that just summarizes what's in the chapter of the text for this week. But I'm going to skip down here to this first. In the software, what is software development article that I've linked to, the software development article describes what is needed for the software development process. And in this process, you can see that there are activities and steps, and most of the activities, only one of which is coding. We start off with a requirements analysis, and a requirements analysis is to extract the requirements of desired software product from the customers. And the customers know what the software needs to do, but sometimes it's hard to understand them completely. And also they might skip steps because they're so familiar with them, they don't think about it. To find out exactly what you need to create, you need to make sure that your instructions are not incomplete, ambiguous, or contradictory. And sometimes that section in finding the requirements is a back and forth process with trying to understand. So during this first phase of software development, what you need to do is to be able to find a way to restate exactly how you're going to write a program. And you do that by using things like pseudocode, which is an English-like translation or representation of software code. You do that by creating visual charts like flow charts or things that use a universal modeling language, UML. And you create the program in such a way that someone who doesn't know how to program can understand what that program is going to do. By being very specific in designing a program and analyzing what it's going to do, you are addressing that you're not going to have to make big changes when you get to the end. So once you restate what a customer needs and how to solve the problem and how you intend to solve the problem, you describe the software to be written in a mathematically rigorous way is what this article says. But in practice, what you're doing is just writing out, if this is true, then do this, otherwise do this thing. And you want to make sure that it's working, and you figure out the architecture and how you're going to create it. Now, after you've done all of those things, which is definitely the hardest part of software development, you go into coding, which is the obvious part of software development. But if you've done the first, especially the requirements analysis correctly, then the implementation should be fairly easy. But keep in mind, another and most often skipped part is the testing, where you design software and you make sure that it runs the way you want. Testing is not click, run, oh, gee, it works. Testing is if I put in 2 plus 5, is it going to give me spaghetti? If the logic is incorrect, but you don't get any errors. Designing and planning for logic testing is an integral part of software development. The second article here is software development lifecycle models. There are various ways to develop software, and kind of the basic one that is sort of representative of the ways that you define software is this one that's going to come up first as soon as my page loads. Sorry, my computer is being super slow today. And that is this right here. In this life cycle that goes in a circle, it kind of makes it sound like it's super easy. First, we get the requirements, and then we design the program, and then we code and implement the program and test the program. And since it's great, we just maintain the program until we need to do more to it, which takes us back to requirements and analysis. Although let me tell you, it's never that easy. And so this isn't a very honest representation of what software development looks like, but more likely there's a bunch of little subcircles. We get the requirements, we try to analyze them, and based on that, we state them to the customer who may or may not agree. And this part could go round in circles for a long time. Then the requirement analysis, once you feel like you've got the requirements down, you start to design the program. And you come up with something on paper that's not using a Python or anything like that, but just a visual depiction of what a program would do, who are the users, what kind of information they'll have access to, how information transfers from place to place, how it's inputted, how it's processed, how it's stored. All of that will be a design. At this point, you present it back to the customers, and the customers will come up with new requirements or a change in the analysis that you weren't quite sure of. And so this in itself gets to be a circle. Now, hopefully at some point you can move on to the third one, which is implement. But once you get back to implement and they're actually using it, I guarantee that there's going to be changes. And then you get into testing, you find problems. So then you have to redesign the solution. So even though this looks like a really simple circular pattern that very quickly gets you through from point A to point B in software development, the truth is it's much more complex than that. There has been other ways of describing that. This one that is listed is kind of just the waterfall approach, that it says we wait until we completely finish the requirements before we can go to the design. This is focusing on requirements being the most important, and then having a foolproof design that's also very important before you even get to executing it. And this, according to this article, shows the advantages and disadvantages. There's a few more models on here, and part of the assignment for the week, if I could get this to move, sorry. 1 second. The assignment for the week, there's a discussion, and in that discussion, I ask you to tell me about software development techniques. And the waterfall method is just one model of software development. And what are some other software development models? Find another model and discuss their similarities and differences with the waterfall model. Which do you like best? You are to post your response and reply to at least 2 others. So that would be an example of what you would say using the advantages and disadvantages. Now for this week, the homework assignment asks that you create a plan. Let me go back. The week 2 assignment down here at the bottom is going to ask you to develop a solution for each of the projects 1 through 10. Now, it says in each of the projects that follow, you should design a program that will contain an introductory doc string. If you don't know what a doc string is, it's basically a description of a program, which is what you're creating. You're going to create the documentation to describe what the program will do, which is an analysis, and how it will do it, which is the design. So you're going to do an analysis and design of the program requirements for all the projects 1 through 10. You'll include suitable prompts for inputs, label all outputs, describe how you're going to test it, what values will you expect to see when the program runs, how will you test for logic errors. Just a note, I do not want Python code for this. I also do not want any of you to just start doing it on Python and come back and answer these questions. Force yourself to do it the right way. It's really easy with these easy prompts in Python to just start on Python and make a program work. But force yourself to do it the right way. Create the doc string. Create the logic, write some pseudocode. If you don't know how to write pseudocode, I have given links and there's a video to watch about what is pseudocode and how to write it. without being too much detail, why should I write pseudocode, writing pseudocode examples? Without too much detail, I don't have very big specifics on how to write pseudocode. It should always be very English-like in structure, but look kind of like programming language, and there's no real rules. Anyway, I hope that helps. So I will get this up and posted, and if you have any questions, let me know. I'll talk to you soon.